Hello and welcome to today's lesson. I'm your hard-working but indefatigable teacher, Mr. Burton. You will need to watch this video and take notes as you go. You may need to watch certain parts of the video a few times to ensure complete understanding. This is your homework and I will check your notes tomorrow before we get started. I hope you learned something.
Okay, welcome to today's lesson. We start elasticity today, and specifically price elasticity of demand. Quick video.
Price elasticity of demand describes how changes in the cost of a product or service affect a company's revenue. For some products, a change in price will dramatically influence how many units the customer will buy. In other cases, price movements have little effect on demand. Therefore, understanding the price elasticity of each offering is crucial to maximizing profit. To calculate elasticity, divide the percentage change in quantity demanded by the percentage change in price. Usually the number will be negative, as price decreases generally induce shoppers to buy more of the product. A number between 0 and 1 indicates an inelastic good. In other words, the customer is relatively unaffected by the new price. Numbers above 1 indicate elastic demand, where shopping behavior changes significantly. Several factors can affect the price elasticity of products. For example, if substitute goods are readily available, the customer will immediately curtail purchases when the price rises. And if the good represents a major part of the buyer's total spending, he or she will be more likely to shop based on price. A new car fits into both of these categories and therefore represents elastic demand. If an automaker dramatically increases its pricing, the customer is likely to shop different makes or hold off on his or her purchase altogether. By contrast, public transportation consumers have few alternatives. Many train or bus riders don't have a car, so moderate changes to the fare will have relatively little impact on how often they ride. Understanding how consumers value a product can be vital for any company. Raising prices can be one of the easiest ways to boost profits, but only if consumers are willing to accept the added cost.
Okay, we know that the law of demand states that as the price of a good increases, quantity demanded decreases, and price elasticity looks specifically at the degree of change in quantity demand in regards to price increases and price decreases. So here we are. Here's our definition. Price elasticity of demand is a measure of the relationship between a change in the quantity demanded of a particular good and a change in its price. Sometimes the change in quantity and demand is large, sometimes it is relatively small. Price elasticity tells us which. There's some calculations here. IB economics is good. There's only one method for calculating price elasticity of demand, and that is a percentage change method. Now there's another method out there a little bit more accurate but a little bit more complicated called the midpoint method, but in this course we don't have to worry about it. So here goes our formula. Price elasticity of demand, we have percentage change in quantity demanded on top and a percentage change in price. So that's percentage change in QD of a percentage change in price. Here's an exam tip. No formulas in the exam. The queen, Q, is always above the prince, P. So quantity above price. Here's an example. If the price of good A decreases by 10%, the quantity demanded increases by 12.5%. Our calculation is nice and easy. 12.5 divided by 10. And we have a price elasticity of demand coefficient of 1.25. Okay, essential statement. For the PED of demand calculation, we take absolute values. Why do we do this? A price decrease of 10% should technically be minus 10. It's falling by 10, a negative number, because it is a decrease in price. However, because we assume the law of demand holds, we can ignore the negative value. A price increase will lead to a decrease. negative value in quantity demanded, and a price decrease, negative value, will lead to an increase in quantity demanded. So the end result will always give us a negative number. We just forget about it, and we term that taking the absolute value. We chop the zero off, chop the negative sign off. Okay, but sometimes the information that is provided about changes in quantity demanded as a result of changes in price are given in numeric terms and not percentage terms. So we need to go away and calculate our percentages, our percentage values, before we can plug those into our PED equation. So here we are, your percentage change formula, original minus new, divided by the original, and we multiply that by 100. An example, a price of good A decreases from $10 to $9, and law of demand, the quantity demanded increases from 1,000 units to 1,200 units. Percentage change in price, 10 minus 9, $10 minus $9, original minus the new, and divided by 10, the original price, multiply that by 100, and we get 10%. In similar fashion, the change in quantity demanded, we have the original quantity demanded as being 1,000. The new quantity demanded, 1,200. We'll subtract that. Don't worry about the negative sign. And divide that by 1,000, the original quantity demanded. And because it's a percentage, we'll multiply that by 100, and out pops 20%. So change in price, 10%. Change in quantity demanded, 20%. And now we can just go and do our calculation very easily. 20 divided by 10, quantity demanded, divided by the price, queen over prince. And out pops our coefficient, 2.0. We can also calculate PED from a demand curve. And this is a reasonably common question in the quantitative paper, exam paper, paper 3. Let's take a percentage change in price, $7 down to $5. The original was $7. Multiply that by 100, 28.6%. Percentage change in quantity demanded, 0.3. So if that information is provided on the demand curve, we can simply pull that information off. We've got P1 and Q1, their original price and original quantity demanded, and the price falls to P2 and quantity demanded increases to Q2. So we can simply read that information off the demand curve and then plug that into what we already know. Working out the percentage change in price, percentage change in quantity demanded, and then simply plugging those two percentages into our price elasticity of demand formula to get a coefficient. And working through that here, we get 2.33, a PED coefficient of 2.33. Yes, but what does it all mean? I hear you scream. I hear you screaming for the last 5 minutes here. Okay, so we've got that coefficient that we calculate lets us know how large the change in quantity of demand is going to be in relation to that change in price. If we go away and do our calculation and we get a PED coefficient that is somewhere between 0 and 1, so it's greater than 0, less than 1, we term this inelastic demand. And what does this mean? This means that the change in quantity demand is relatively unresponsive to changes in price. So the quantity demand decreases less or increases less, it changes less than the change in quantity and change in price, sorry. So for example, if price increases by 10%, quantity demand decreased by 5%, we would say that is inelastic demand. So we end up with when there's inelastic demand, we end up with a relatively steep demand curve. The change in quantity demand is relatively unresponsive to changes in price. So we can see that a large change in price, a relatively large change in price, relatively small change in quantity demand there. And an example here would be a good that had relatively few substitutes, such as petrol. This is inelastic, at least in the short term. It's needed for transport. It's difficult to find an alternative product. In the long term, households can sell additional cars, take public transport, and local governments can provide extra public transport infrastructure. But in the short term, a good like petrol has relatively inelastic demand. So that's a good example to use in your exam responses. Now, elastic demand is if we get a PAD coefficient greater than 1. Greater than 1. So it's anything over 1, we would term that being elastic demand. The change in quantity demanded is relatively responsive to changes in price. So the change in quantity demanded is greater than the percentage change in price. An example would be price increasing by 10%, and we get a huge fall off in quantity demand decreasing by 20%. This is a relatively flat demand curve, and a change in price results in greater change in quantity demanded for the good or service. Demand is elastic with respect to price. And an example would be a good with lots of substitutes, such as shampoo. And we know that discounting is a popular sales strategy in fast-moving consumer goods. Lots of substitutes. Any price increase results in consumers switching to an alternative competitor's product. Now, there are a few more special case PZ values that we'll need to consider here. Sometimes PED equals 1, and we call this unit elastic demand, where the change in quantity demanded is exactly proportional to changes in price. So, for example, price increases by 10%, quantity demanded decreases by 10%. And this results in a sort of curved demand curve here. Unit elastic demand, the change in quantity demanded is exactly proportional to changes in price. PED equals 0, we call this perfectly inelastic demand. Quantity demand is completely unresponsive to changes in price. For example, if price increased by 10%, quantity demand would not change at all. And this is this perpendicular demand curve, straight up and down. Quantity demand is completely unresponsive to changes in price. Here, a change in price results in no change in quantity demand for the good or service. Demand is perfectly inelastic with respect to price. Not too many instances of here that we can reel off as examples, but one example would be the only type of drug in the market that cures a serious disease. In 2014, a new hepatitis C drug came to market, an innovative treatment offering a cure for a disease that didn't have one before and desperately needed one. Now, Big Pharma here put a price tag of $84,000 for a 12-week course of treatment. And this was enough to make it the most expensive prescription drug in America. PED equals infinite. We call this perfectly elastic demand. Quantity demanded is infinitely responsive to changes in price. So, for example, price increases by 10%, quantity demanded falls away altogether. Any price increase and none of this product will be bought. And this is a horizontal demand curve. Quantity demand is infinitely responded to changes in price because we're basically dividing by 0 on the bottom. And this is a situation in perfectly competitive markets, large quantities of identical products being produced and sold. And this is common with commodity goods like iron. If one producer raises its prices, consumers are going to immediately switch and purchase from other firms supplying that market. So that producer, in a perfectly competitive situation, an increase in price, all their customers are going to leave them and go and purchase an alternative identical product from a nearby competitor. So our 3 special case PED values. What determines price elasticity of demand? We have the number and closeness of substitutes. The more substitutes out there, the greater likelihood of consumer switching to another product in the face of a price increase. So for example here, toothpaste is sold in a highly competitive market where there are many substitute brands. If the producer of one brand increases its price while other producers hold their prices constant, then a large number of consumers are going to switch to other brands. Conversely, if the price of toothpaste is discounted by a producer, then it's going to see a more than proportional increase in its sales. Quantity demand is going to increase more than proportional to the decrease in price as consumers switch to a lower price brand. Our second, necessities versus luxuries. Like any other normal good, when income rises, demand rises, but the increase for a necessity good is less than proportional to the rise in income. So the proportion of expenditure on these goods falls as income rises. So for example, electricity, it's relatively inelastic. It's essential. It's a utility. It's consumed by all households. Consumers can cut back on their electricity use to a point when faced with price increases. But in most cases, we can't just switch to another product that serves the same function. What else will keep the lights and the television on? In contrast, luxury goods like manicures are relatively elastic. Having a manicure is a luxury. It's indulged in now and again by certain consumers. Not me, but perhaps other people that I know. It is relatively easy to cut back on the number of manicures one may have as the price of them increases. I cut my own nails. Lots of people cut their own nails. Length of time is an important one. For non-durable goods, elasticity tends to be greater over the long run than the short run. In the short term, it could be difficult for consumers to find substitutes in response to a price change. But over a longer period of time, consumers can make those changes in their purchasing behaviour. So, for example, if there's a sudden increase in petrol prices, consumers may need to fuel their cars with petrol in the short run, but may lower their demand for petrol in the long run by switching to public transport, carpooling, buying more fuel-efficient vehicles, buying electric cars. But this tendency doesn't tend to hold for consumer durables. The demand for durables cars, for example, tend to be less elastic as it becomes necessary for consumers to replace them with time. So consumers may hold on to their old cars for a few years longer if faced with steep price increases for new cars, but eventually they're going to need to replace their existing model. And proportion of income spent on a good. Now, the proportion of a purchaser's budget consumed by the item can be an important factor in determining its responsiveness to price. Products that consume a large proportion of a budget will tend to have greater elasticity, and the relatively high cost of such goods will cause consumers to pay attention to the purchase and seek substitutes. And an example we saw in the introductory video was a house price and cars. So these are relatively expensive. They're a large proportion of a consumer's budget. Price increases here will result in consumers shopping around for substitutes, lower priced houses, lower priced competitive goods. And in contrast, demand will tend to be inelastic when a good represents only a small proportion of a budget. So, for example, a 20% increase in the price of a plane ticket to Europe will result in a proportionally larger decrease in quantity demanded than would a 20% increase in the price of salt. Let's have a look at PED along the demand curve. Okay, the values of PED are going to change as we move up and down the demand curve. In the top half of the demand curve, where prices are high and quantity demand is low, the demand curve is said to be price elastic. In the lower half of the demand curve, where prices are low, the quantity demanded is high. Demand is price inelastic. And at the very midpoint of the demand curve, there is unit elastic demand. The change in price is exactly proportional to the change in quantity demanded there. So here we are in the lower half. Now, because the change in price results in a large percentage change, so we got from $10 to $15 there, that price increase, that's a 50% change, whereas change in quantity demanded is relatively small, so it's from 80 to 70, and that results in a relatively small percentage. Whereas as we head up the demand curve, we can see that the percentage change will become lower and lower as we move up, and the percentage change in quantity demanded becomes greater and greater. So we see in the final, in the red dashed lines there, the change in quantity demanded from 20 to 10, that's going to be a 50% decrease in quantity demanded, as the percentage change from 40 to 45 is relatively small, the percentage value. So we have an inelastic part of the demand curve below the midpoint, and an elastic proportion of the demand curve above the midpoint. And at that very midpoint, PED equals 1 unit elastic demand. Now the reason is simply the way that the PED values are calculated. So when the price is high, the percentage change is relatively small. $40 to $45 results in a 12.5% change. And the percentage change in quantity demanded is relatively large. So 20 to 10 units, that's a change of 50%. And when we go to the other end of the demand curve, this proportionality is reversed. When the price is low, the percentage price change is relatively high. If we move from $10 to $15, that's a big 50% change. And the percentage quantity demanded, the change there is relatively small. So from 80 to 70 units, the percentage change here is 12.5. And that's it. That's the sole reasoning. It's all to do with the percentage change values that come out. Okay, total revenue. This is an important, often examined concept in IB economics. Total revenue is calculated by price of a good multiplied by the quantity sold, i.e. the quantity demanded. So total revenue is price times quantity. And we know that price elasticity of demand is determined by the response of quantity demanded to changes in price. Using this price elasticity information, firms can determine the best price of maximizing revenues, and from revenues comes profit. Okay, moving down the demand curve, total revenue continues to increase as the price decreases up until a point where we get that unit elastic demand, PED equals 1. Then moving further down the demand curve, PED becomes inelastic and total revenue decreases with further price decreases beyond the point where PED equals 1. So we know total revenue is then maximized where PED equals 1, that very midpoint. Continuing on with this total revenue, so we need to consider elastic demand and inelastic demand and how that affects total revenue. So a firm's total revenue, as we said, is calculated by price times quantity demanded. So the value of total revenue is represented in these boxes here, in the yellow rectangle. A price increase with elastic demand results in a relatively greater change in quantity demanded than change in price. So the new revenue here is calculated by P2 times Q2, and it's represented by the yellow rectangle again. And we can see that the change in revenue from the price, the revenue lost by an increase in the price, and the revenue gained by an increase in price. With elastic demand, an increase in price, the revenue lost is going to be greater than the revenue gained by an increase in price. If we have an elastic demand curve, that relatively flat demand curve, firms are going to lose revenue by raising their prices, and they will gain revenue by decreasing their prices. On the other hand, with inelastic demand, the opposite holds. An increase in price results in increased total revenue, and a decrease in price will result in decreased total revenue. So here we are at our initial price point, P1, resulting in quantity demanded there of Q1. Price times quantity demanded, revenues are represented, the value of revenues are represented by the yellow rectangle here. We'll have a look at a price increase, a large price increase, 25% from P1 to P2, results in a proportionally smaller quantity demanded being in the market here. So increase in price of 25%, fall off in quantity demanded of 5%. So new total revenues there. What's the change in total revenue? Revenue lost by the increase in price versus revenue gained by an increase in price. So we can see that the revenue gain is greater than the revenue loss. So firms facing inelastic demand will always gain total revenue by increasing their prices, at least in the short run, and lose total revenue by decreasing their prices. So let's just spell this out quickly and clearly. So price increase, total revenue decreases. We know that demand is elastic. We have a value greater than 1. A price decrease, total revenue increases. Demand is price elastic. A price increase, total revenue increases. Demand is price inelastic. And a price decrease, and we see that total revenue decreases, we can say that demand is price inelastic as well. Now, when price increases, total revenue is unchanged. We know that total revenue is maximized. Demand is unit elastic. Price decrease, same result. Total revenue being unchanged. We know that total revenue is being maximized. Demand is unit elastic. There is no change to total revenues. Okay, so for elastic goods, this is a good, easy way to remember all this information contained in the table. All you have to remember, for elastic goods, total revenue moves in opposite direction to price. So price increases, total revenue decreases. Price decrease, total revenue increases. They move in the opposite direction for elastic goods. Same direction for inelastic goods. And we don't have to worry about unit elastic because we know all about that already. So elastic, opposite direction, total revenue, and total revenue moves in the same direction for inelastic goods. Elasticity has some important implications for indirect taxes.
An indirect tax is levied on goods or services rather than on an individual or a company. One example of an indirect tax is the sales tax customers pay for items they purchase for their personal use. The store collects an indirect tax from each customer in the form of an additional cost placed on the purchases. The state or county determines the amount of the sales tax, which is normally calculated as a percentage of the total purchase cost. The store eventually files a tax return and forwards the tax money it received from the customers to the government. With indirect taxes, the taxpayer can shift the burden of paying an indirect tax to someone else, unlike a direct tax. Federal income tax is an example of a direct tax. There is no intermediary between the taxpayer and the government. Indirect taxation tends to take a greater toll on people with less money. That's because the poor pay the same amount of tax as the wealthy.
Okay, so a definition there, a tax placed on good or service that a government imposes on producers. So we all know about sales taxes, GST, goods and services tax, and VAT, value added tax, and we get excise taxes as well, but more about that later. Okay, so if we have elastic demand, which is indicated by the relatively shallow sloping demand curve there, relatively flat demand curve we say. Now we know that an indirect tax is going to decrease supply. It's going to shift the supply curve to the left. Now we can calculate indirect tax revenue, tax per unit times quantity demanded. Inelastic demand, that steep demand curve. What's the effect of an indirect tax on inelastic demand? Because consumers on inelastic demand are relatively unresponsive to increases in price, and that's what a tax does. It increases the price of a good. The quantity demanded, the decrease there, is relatively small. So for any given indirect tax, government tax revenues are going to be higher the lower the price elasticity of demand. Lower price elasticity of demand means inelastic demand. So the lower the price elasticity demand of the good or service being taxed, the higher the government tax revenues. So on an inelastic goods such as cigarettes, alcohol, petrol, where the demand for the good or service is inelastic, any indirect tax placed on that sort of good or service is going to result in a relatively large government tax take. Whereas with goods or services where the demand curve is relatively flat, it's elastic, government bangs a tax on, indirect tax on, the price will go up, but the quantity demanded is going to fall right away. So not so much tax gained on elastic goods, whereas quite a lot of tax is gained, a relatively larger proportion of tax is gained on inelastic demand. And one further application, we have primary commodities to consider. Now, primary commodities are those goods that are extracted or produced directly from natural resources. So these coming straight from the factor production we term land. Things like forestry, fishing, agricultural products such as food, corn, wheat, cotton, rubber, etc. And products extracted from the ground and mining industries such as gas, coal, oil, iron, copper, etc., etc. Now, many primary commodity goods have a low price elasticity of demand. They are price elastic mostly because they are necessities. There are few substitutes. So, for example, oil and food have a high degree of necessity, low substitutability. So it's been estimated that food has a price elasticity of demand in developed countries of between 0.2 and 0.25, and we know that's relatively inelastic. It's not even approaching the unit elasticity demand of 1.0. So inelastic demand for food, primary commodities. And the price elasticity demand for manufactured goods is relatively price elastic. So even if these goods are necessities, they're likely to have a relatively higher degree of substitutability. It doesn't apply to all manufactured goods. Medicines are a necessity and are still under patent protection. So a couple of things there to consider in regards to price elasticity demand and primary commodities, manufactured goods. Thank you.